In this recording, we're going to learn to recognize the difference between exponential and linear growth. Now, you already have some experience with this. Obviously, you know what a line looks like. You know what an exponential curve looks like if it's graphed. But how do we recognize it in a table? And in addition to that, if we are able to first recognize that it is a linear function, well then, can we identify the slope? Okay, that's the change that's going on in the table. And if it is an exponential function, one that is based on multiplying each time, can we identify the base, the multiplier? Because if we can do that, we're kind of halfway there to getting an exponential or linear model. Just need to know the initial amount. So looking at this first couple of tables here in this example, wants us to say which one's a linear and which one's an exponential function. So let me give you a little think time. Play the recording when you've thought that through, and you can explain why you think a certain one is linear and the other one is exponential. All right, hopefully you paused and thought about this for a little bit. So the first one is basically looking at patterns. What are you seeing? Well, I see it goes from 5 to 10. Well, that could mean a couple things. It could mean I doubled, or it could mean I added 5. So I can't get away with just looking at one pair of points. I'll keep looking. Okay, so the adding 5 is out, right? Because that would be 5, 10, 15, 20. That doesn't happen. It doubles. So we can put a little times 2 here. Okay, and since we're multiplying by 2 each time, and I can see that pattern continues, that's going to mean it's exponential. All right, well then I guess obviously the second one's linear, but let's confirm that. What's the pattern? So hopefully you recognized 8 to 11 is plus 3. Let's see if that pattern continues. Yep, 11 to 14 is plus 3, and so on. Keeps adding 3 each time. So that's linear. So at this point, I need to give you a little practice time. I need you to look at each one of these tables and determine, do we have a linear pattern where we're adding? I guess it could be subtracting also, right? Because adding a negative is the same as subtracting. Or do we have an exponential function? And that's where we're multiplying each time. And then if you can do that, I'd also like to know what's the slope or what is the base. So like up here, I would have said the base is 2. And for this one, I would have said the slope is 3. The average change as the x's increase by 1, the y's are increasing by 3. So that's 3 over 1. Change in y over change in x. Okay, so work out A, B, C, D, then play the recording when you actually go all the way to F if you can on the next page. Play the recording when you want some feedback. All right, if you did not pause and work these out, please pause and actually think and try and get as far as you can. We're going to look at these answers. So the first one's linear. Okay, the slope's 3. Just like before, we're adding on 3. So on. Second one is exponential. The base is 3. We're multiplying by 3 each time. I want to point out something that can help us with later problems. Maybe those couple were easy, but then on others you might have been stumped. I want to point out how we can get this 3. If it's not immediately obvious to you how to get from 2 to 6 and 6 to 18 and 18 to 54, one thing you can do is find the common ratio, is what it's called. So you can do 162 divided by 54. You grab a calculator and figure that out, and it works out to be 3. Similarly, if I did 54 over 18, that works out to be 3. And obviously we know that 18 divided by 6 is also 3. It's the common ratio. Just make a note of that. And that's also happened to be the base, right? That's the multiplier. Another way to say it. All right, so we can get that by dividing a term divided by its previous if we can't figure out what that multiplier is. So I think in the next example, it was a decrease. So the question is it going down by, see these first two go 32, 16. So the question is, which one is a linear pattern? Which one is exponential? Well, I think I can see here that this one went down by 16, but that subtracting 16 pattern did not continue. Maybe it's obvious to me what the pattern is, maybe not, but I can do 16 divided by 32. I can do 4 divided by 8, and what I'm getting each time is half, or 0.5. So that's the base. Multiply by half, multiply by half. And of course we know that if the base is less than 1, but greater than 0, it's decay, right? So that's a decay situation. This example, we did decrease by 16 each time. So it was linear. And so our slope is negative 16. Hopefully you made some progress with the next page as well. If not, please pause and do make some progress. Wow, we're getting into some fractions. Hope that didn't intimidate you. If it did, you got to use our technique of the common ratio, right? If you're like, I don't know how to get from 16 to 20 and then from 20 to 25, well, it's clearly not going up by the same amount. So I think we can rule out linear, right? So we can say it's definitely exponential, but what is the base? Right, so take a moment to try to figure out the base, then play the recording when you're ready. All right, so hopefully you did a little dividing here, right? You got to divide 20 divided by 16. I'll just kind of do a little showing of where that came from. 20 over 16 works out to be 1.25. And if you were to do, so that's times 1.25. And if you were to do the same thing, if you were to do 25 divided by 20, it's also 1.25. So that's our multiplier each time. So the base is 1.25. If I were to do 25 times 1.25, it's going to come out 31.25. All right, so that's the constant multiplier each time. The one in example F, hopefully you can see it's decreasing by 20 each time. So that's going to be a linear pattern. We have a negative slope of 20. Example 2, it says, all right, do we have a linear or an exponential, and then which one is the best model? So, well, you got to kind of look at your data. Why don't you take a moment to do that and see what your choices are. I hope you paused and thought that through. Well, they're not going up by the same amount each time, right? It's not a common difference. If I do 20 minus 10, it's not the same as 40 minus 20. So I've got a multiplier here, so it's clearly going to be an exponential. So cross out two choices that right away you're like, these aren't exponential. Well, it's definitely not that one, and this is, I guess, would have been choice 3. It didn't get very leveled very well. All right, so those are linear, right? Those are y equals mx plus b. Those are out. Question is, which one of these it is? Well, they both have a slope of, or excuse me, a base of 2, and we can see that that's the pattern, times 2 each time, times 2 each time. But the question is, what's our initial amount? 10 is the amount, not the initial amount. 10 is the amount when x is 1. What I need to do is squeeze in a little 0 there. I need to know what's the initial amount that when I multiply it by 2, I get 10. And hopefully that number is obvious to you. If not, you can continue the pattern this way. Let's do 80 divided by 2, 40 divided by 2, right? 10 divided by 2 is 5. All right, so that would be our initial amount. And when we think about our y equals a, our initial amount, times b, our base, to the x power, that satisfies that equation. We're going to skip this challenge example. We'll do that in class. The last thing I'd like to do is have you look on the following page where we've got a graph and a table. And we'd like to know, well, what is the equation of this exponential decay function? I guess the first thing is, why do we know it's exponential decay? How do we know this? Hopefully you can look at the graph and just see it's not linear. Right, so we can rule out linear. It is exponential and it's decreasing every time. So let's see if we can pinpoint some points on this. Obviously the table's going to be easier. We've got the points all laid out. But if you could put your pen on some points that fall on the grid, that are exactly on the grid, that could be helpful. Pause the recording when you have some points. Okay, so hopefully you identified that point there. Let's see, we've got this point right here. Maybe we could organize these points in a little bit of a table. Maybe over on this side. Let's see, I've got mostly negative x values. So at -2, it's hard to tell exactly, but it is that point. It's not quite -8. So it looks like I've got -2 makes 9, -1 makes 3, 0 makes 1, and then the pattern continues. So I think that'll give me a decent sense of what's going on. I think I can see the pattern already, and hopefully you as well can. Keep in mind, when we write our equation, we're looking for something of this form. Y equals A times B to the x, where B is our multiplier, or our base. And A is our initial amount. So I think you have that information here. Why don't you see if you can flesh that out and play the recording when you have your answer. Okay, so hopefully you recognized this is being multiplied by 1/3 each time. Again, if you couldn't figure that out, you got to do 9 divided, you got to do 3 divided by 9. If you did 9 divided by 3, you'd get 3, right? But clearly they're not multiplying by 3 each time, they're decreasing. So I have to have a base that's less than 1. So I got y equals, I got my initial amount here. Well, when x is 0, what's y? So y is 1. So 1 times 1/3, all raised to the x power. Example B is similar. We got to know what the initial amount is. Okay, and that's going to be the y-intercept. That's when x is 0. Just like when x is 0 on this graph. Let me just draw a little arrow. There's our y-intercept. What's the multiplier? So let's see if we can figure that out. What's going on each time with these points? Again, you're in charge. You can pick the easiest points you like. So if you don't feel comfortable with the decimals, then don't use them, right? What's the thing that we're multiplying by to go from 25 to 5, and then from 5 to 1? If you couldn't figure that out, do a little 5 divided by 25. It's clearly something less than 1, right? So 5 over 25 is 1/5, or 0.2. So we used a fraction in the other one. Let's use a decimal in this one. So as long as it's a terminating decimal, I'm okay using that decimal. So we'll do times 0.2 times 0.2, and we could play with that, and well, clearly 1 times 0.2 becomes the next point. That makes tons of sense. So now we just got to put it all together. Play the recording when you have your answer. Okay, so if you wrote y equals, I need the initial, which is 1, right here, times the base, which is 0.2, all raised to the x power, because we have an exponential function. Thanks for watching.